Hello, a Rosie math teacher coming at you from my third period, accelerated grade 7 math class. We are working today on lesson 13-2, theoretical probability of repeated experiments. Now, we have already done a survey, a small survey of 8 students in the room for their favorite flavor of ice cream. I am so impressed that so many are choosing as their top flavor, my second favorite flavor, mint chocolate chip. 6 out of 8 students in this room do prefer mint chocolate chip. Now, if I wanted to also see that value as a decimal, I would plug this in my calculator, 6 divided by 8, I would write down that decimal. If I then wanted to change it to a percent, I would scoop that decimal point, how many times? 2 times to the right, and I would get my percent. Hold on, to the right, you are correct. All right, and then for chocolate ice cream, we did have 1 person out of 8, their favorite flavor is chocolate. Same results for black raspberry, 1 out of 8. Happened to be me. I was part of the group. Black raspberry was my favorite flavor of ice cream growing up. I think you can only get it in Maine. Somebody can comment and let me know if there's any place locally that I can get black raspberry ice cream. It is the best, y'all. Okay, now that we know that whatever favorable outcome we are looking for becomes the, what position number? Numerator. Out of all the flavors that were discussed at that moment, the total number becomes your denominator. So the probability of an event goes number in the top, number of favorable outcomes, number of people who all liked mint chocolate chip ice cream. It always goes over top of total number of outcomes. In our survey, we only surveyed 8 people, so that meant our total number of outcomes, 8. You always include that numerator within your denominator. All right, let's go ahead and look at the very next page. And guys, in the case of this particular spinner, we can clearly see it is labeled 1, 2, 3, 4. It's also yellow, green, blue, red, but we're using the numbers today. The spinner shown is going to be spun twice. What is the theoretical probability of spinning the same number twice? Now guys, it was very kind of them. They went ahead and wrote out the sample space. Remember that in the first row, we could make up a sample space of beginning with a 1. In the second row, we could begin with a 2 for that first spin. In the third row, a 3. In the fourth row, begin it with a 4. And then remember, you would make columns to do your 1 through 4 again. So our columns would be 1, 2, 3. Sorry, that's a messy 3. 4. Do you see how our results always showcase begin with a 1, end with a 1, begin with a 2, end with a 1? Do you follow how to read this chart? Okay, and yesterday we also learned, let's review this quickly, how many possible outcomes are there in a single spin? How many possible outcomes on this spinner in a single spin? 4. So we write 4 as our base. How many times are we going to spin?
2.
Twice. So that becomes our exponent. That tells us how many possible events we have, how many possible outcomes we have when we spin the spinner twice. What is 4 to the second power equal to? 16. How many different variations do we see inside of our chart?
16.
Also 16. Okay, are you understanding how we get 16 possible outcomes when spinning 4 areas twice? Okay, so another question that they're going to ask you later, so I'll just point it out right here because this conveniently already has it laid out for you. What is the probability for the favorable outcome of the 2 digits being spun matching 2 times in a row? So for example, 1, 1, 2, 2, and so on. So guys, look at your chart. Please circle right now all of the matching numbers that you see. Circle all of the matching numbers that you see. What is the first thing you circled? 1, 1. And the second?
2, 2.
Keep going.
3, 3.
And?
4, 4.
So how many times did you get the outcome of same number happening twice?
4 times.
4 times. Out of how many spins total? 16. Now, if I simplified this, I could divide both pieces by 4, and I could get what?
1, 4.
And what would that be equal to in decimal form?
0.25.
0.25. How about in percentage form?
25%.
25, excuse me, percent. Do we understand how you could get 1/4 is the same as 0.25 is the same as 25%? You need to know in this lesson how to create a simplified fraction, decimal form, matching percentage form. How many scoops do I do with my decimal to get the percent?
2 times.
2 times, always to the right. If I'm converting a percent to decimal, I would go 2 times to the left. So it just depends on which thing you are changing from and to. How about your check item? A fair coin is flipped twice. What is the theoretical probability of flipping heads twice? Now let's look. First, set up a table very quickly. It doesn't take long, guys. What could happen in the first flip of a fair coin? You could land on heads or possibly tails. And then in the second flip of a fair coin, you could possibly land on what? Heads or tails. Now fill in your chart. Under the H and across from the H, I shall write HH. Across from the H, under the T, I shall write HT. Across from the T, under the H, I shall write excellent. Across from the T, under the T, I shall write double T. There you go. Now, as I look at that, what is the theoretical probability of flipping heads twice? Where do you see heads being flipped twice? Where the letters say what? H, H. Don't you agree only here? Because this is heads, tails, tails, heads, tails, tails. This is the only place. So how many times were heads flipped twice? Okay, I think when you said 2, you're thinking about the fact that the heads were flipped twice. What I'm asking is, how many times at the end of the 2 flips would you say heads were flipped 2 times in a row? 1 time, because there's only 1 double H. So to the right, please write 1 as your numerator for the favorable outcome of double H. Out of how many times in my entire chart? Out of 4 possibilities in the entire chart. Again, same as above. What would that be as a decimal? 0.25. What would that be as a percent? 25%. Now, let me show you another way you could solve this mathematically. When I am flipping a fair coin, on the first flip, what is the probability that it will land on the preferred event heads? 1 out of 2. Write that down. That represents the probability of heads on the first flip. Then write a times indicator. Now on the second flip, also write the probability that you will land on heads. Again, it is what? 1/2. Then you simply multiply. Multiply numerator by numerator and you get 1. Multiply denominator by denominator and you get 4. Giving us, again, the same answer we already knew, yes? Do you understand how you can either solve it by using a table or solve it by multiplying the likelihood times the likelihood again? Okay, we're going to go straight to your practice page and practice a little bit of something there. So let's go to your practice page right now. Oopsie daisy. Don't pause that video and copy all those answers that you just saw. All right, for item number 1 on today's homework, they want you to find the theoretical probability of each event, express your answer as a fraction, decimal, and percent. Round to the nearest thousandth if necessary. How many spaces beyond the decimal is the thousandth place? 3 spaces. So you would underline that, draw arrow to the right. If the digit to the right is more than 4, raise the score that sits on the floor. Yes? If it is not, you do nothing with it. You just lose everything to the right and keep everything to the left. Number 1, flipping 3 heads when flipping a coin 3 times. Okay, so on the first try, what is the fraction representing the likelihood of landing on heads?
1/2.
1/2. Write that down. Now, how many times are you going to flip this coin?
3 times.
3 times. So, times, what's the chance on the second flip of the coin?
1/2.
1 out of 2, so 1/2. Do I need to write 1/2 again?
Yes.
Yes, to represent the third flip. So First flip, second flip, third flip. Am I finished yet?
No.
Well, am I finished writing times 1/2?
Yes.
Yes. Now I just need to multiply all my numerators. 1 times 1 times 1 equals 1. Think carefully before you do this last one. Do not say 6. 2 times 2 times 2 equals
8.
8. Excellent job. So in a moment, on your calculator, you will type 1/8 or 1 divided by 8. You will write down the coordinating decimal value and the coordinating percent. Do I have any questions on how you will do number 1? All right, I already know that some people are struggling when it comes to an item like item number 3. Let's read the situation. A deck of 10 cards shows the numbers 1 through 10. Each card is replaced after the first one is drawn. Find each theoretical probability. Express your answer as a simplified fraction. Now, online might ask you to represent it a different way. We're going to stick with the simplified fraction for now. So they want to know the first time there's the probability of you pulling out an 8. Now, in these 10 cards, what is the chance if they're numbers 1 through 10? How many of them have an 8 written on them? 1. That is your numerator. How many cards are there in all? 10. Do you see how we got the probability of pulling an 8 on the first try? Do you follow? I see someone looking concerned. Okay, how many cards were labeled with an 8?
1.
1. Do you get how we got the 1? How many cards were in the hand to begin with?
10.
Do you see how we got the 10? Okay, great job. Guys, now write times. Now let's review what a prime number is. It is a number where its factors only include 1 and itself, but we don't count 1. So think about the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is 2 a prime number?
Yes.
There are no other factors besides 1 and 2. Whole numbers. Okay, so 1 times 2 equals 2, so 2 is a prime number. I'm counting that. 1 finger up for that. Is 3 a prime number?
No.
Does it only have factors 1 times 3?
Yes.
Then it's a prime number. Count that. Is 4 a prime number?
No.
No, because of 2 times 2. Is 5 a prime number?
Yes.
Yes, because only 1 times 5. Is 6 a prime number?
Yes.
No, because of 2 times 3. Is 7 a prime number?
Yes.
Yes, because only 1 times 7. Is 9 a prime number? No, because of 3 times 3. Is 10 a prime number?
No.
No, because of 2 times 5. Are we following prime numbers? How many fingers are we holding up at this point? 4. So please write 4 as your
Whole number.
numerator. Okay? And what is still our denominator? Because we put that first card back in the stack and we still pulled out of 10. So what is my denominator?
10.
10. Excellent. Now let's multiply. Numerator times numerator. 1 times 4 equaling 4. 10 times 10 equaling 100. Let's simplify. Divide both pieces by what? I would divide them both by 4 because they both can be divided by 4. What is 4 divided by 4? What is 100 divided by 4? 25. So in a moment, is 1 over 25 truly the answer in simplest form? And if they want decimal, you will simply put this in your calculator and you will see the decimal. 2 scoops to the right and you will get the percent. Okay, great job. Let's talk a little bit about the marbles. Numbers 5 and 6. A bag contains 2 red, 3 blue, 3 green, 2 orange, 5 yellow. Each marble is replaced after the first one is drawn. Find each theoretical probability. Class, how many are green?
3.
3 are green. What is my numerator?
3.
3. Now, if you have not already done so, what do you need to do to find the total number of marbles? Add up all the numbers. Wave at me if you already know the total. Go ahead, what is it?
15.
Excellent, you are correct. Do you understand why your first ratio is 3 out of 15? Because 3 marbles are green out of 15 marbles in all. Do we always need to be sure we add the 3 of the green in with the total? Yes, don't ever leave that out. That's a common mistake. All right, and then what is the second color we're looking for?
Red.
Red. Our favorable outcome this time, it's whatever we're looking for, just like the ice cream. Your favorite flavor is always the one you're looking for. The favorable outcome is the one you're currently looking for. We're looking for red. How many are red?
2.
2. 2 are red out of how many total? Because we put those other marbles back in? 2 out of 15. What will you do in a moment to find the probability of this scenario happening? You will multiply those 2 on your calculator. You will simplify, and you will find the correct fractional form, and you already know how to find the matching decimal as well as percent. I want you guys to look at number 7. Number 7 says, find the probability that 2 of these numbers would have an even sum. All right, remember this spinner is being spun how many times? Twice. So this time, I want you to go back to your picture of this spinner that we had in our textbook earlier. Can you go back to that page? Now we're just looking for when 2 numbers would have an even sum. You're familiar with even numbers, right? 2, 4, 6, 8, 10, 12, 14, and so on? Okay, so let me go back to this page, and this time I'm going to draw a red box around something when it has an even sum. This time, how about 1 plus 1? That's 2. Is that an even sum? Yes. So I'm going to put a box around that. I'm going to keep going across the row. How about 1 plus 2?
3.
It's 3. Is that an even sum?
No.
No. How about 1 plus 3?
4.
Is that an even sum?
Yes.
4 is an even number. 2, 4, 6, 8, 10, 12, and so on. Okay? How about 1 plus 4?
5.
Is that an even sum?
No.
No. Are you understanding what you need to finish doing, going through the row that begins with 2, the row that begins with 3, and the row that begins with 4? Do you understand how to continue to find the correct number where it has an even sum? And that would be the numerator out of, what is your sample space including? How many options? 16. So whatever you get, you will put it over 16. There is one more I want to chat with you about very quickly. It's on the back side, and let me talk you through it. On the back side, item number 9. Candace is flipping a coin a certain number of times. Do we know the number of times?
No.
No. The theoretical probability of her flipping tails on all flips is 1 out of 32. How many times is she flipping the coin? Now, first of all, she's flipping a coin. So what are the chances of her flipping tails on the first flip? 1 out of 2. Please write 1 out of 2. Now, is that what we're looking to see? No, we're looking to see 1 out of 32. Shall we go ahead and represent a second flip of the coin?
Yes.
What are the chances of landing on tails in the second flip? 1/2, 1 over 2. Will that give us a total possibility of 1 out of 32? No, it will not. Shall we flip the coin again? Yes. So times what?
1/2.
Excellent. Will that give us 1 out of 32? No, it still will not. I am not going to finish this to show you the answer, but do you agree? You understand to keep writing times 1/2, times 1/2, times 1/2 until the calculator and you agree that it would equal 1 over 32. Guys, you get that you will just always get 1 for the numerator, won't you? So you want to keep writing another 2 until you multiply all those 2's and you get 32. Again, this is not the correct answer. I'm stopping here. I will let you continue. I wish you well on your work for today. I think you have a good start. Go ahead and get busy.